This month's gonna be hectic for me. Ano hindi? Sino dito? Oh, so parang bumalik sila sa feeling ko nakita ko na yung trailer niya. Oo.
Hello everyone, good morning. Good morning. Do you have any question? No? Okay. Shall I ask question? So what we talked about last time? We talked about relation between two variables, right? Explanatory and response variable, right? So we talked about a scatter plot too, right? Then we talked about form of a scatter plot. What kind of forms we have? Linear or curvature, right? And then what else we talked about? Direction of a scatter plot. Positively associated and negatively associated. And then we talked about the strengths of scatter plot, right?
Yes.
What is that?
Strong.
Or weak, right? Okay, good. So now again we will talk about the direction of a scatter plot. And there is another definition of direction of a scatter plot. We will talk about that. And there is you remember I said we never can rely on our eyes. So we are going to talk about the measure of relation, which is correlation. So today we will talk about measure of relation also. So now let's talk more about direction of a scatter plot. So either you said what? Positive?
Positively
Associated. Or negatively, right? So what was exactly? So two variables are positively associated when they have a slope. Slope is? When a slope is? Positive. And then negatively associated when a slope is less than 0. Negative, right? And then we said positively associated means one variable increases, another also increases. Or one variable decreases, another will decrease. So right? So both of them have the same movement. Correct? So now I have an example for positive associated. And I will talk about this definition using my example. So the first one, the second one, and then the first one. So this is my example. I have one variable. Your exam score. And my level of satisfaction. So what happens if you get a good score? What happens to my satisfaction? Yes. So obviously these two variables are positively associated, right? Is that correct? So your exam score increases, my level of satisfaction will also increase. So let's have a positive slope here, and then let's say there are some points here because this is a scatter plot, right? And okay, so there are individuals like exam scores. This student have exam score, okay? So there is this student here. I mean this exam score here. Which is the highest exam score probably. And then my level of satisfaction, let's say out of 10, 1 to 10, I'm so satisfied, right? And then there is one exam score here, which is maybe, let's say 60%. I'm not satisfied at all. Okay? So, oh, sorry. You have another chance. You can make it up. Next exam. Okay? So, now, look at this. The upper average of this variable, this is the upper, what is that? Satisfaction level, right? Happens with the higher exam score, okay? So, higher average of one variable occurs with higher average of another variable, right? And then lower average of one variable happens with lower average of another variable. So we have this definition. Two variables are positively associated when above average values of one tend to accompany above average value of the other, right? So now we just saw that. And then below average value also tend to occur together. Means below average of this one and below average of this variable. So this is one other definition of negatively associated. Okay? Do you have any question? This is important. This definition here is important. Okay, so this was positively associated, and now I want to show and define the negative associated association again. So let's say exam score. Now we have a negative association. What happens if your exam score is low? I'm mad. Am I? So level of madness. Level of angriness. Angriness. Angry. Level of just angry? Anger. Right. Good. Okay. So let's say 1 to 10 again. Okay? 1 to 10. So obviously if your exam score is lower, I'm more mad or angry. If your exam score is high, I'm less angry, right? So this is a negative association, correct? So we have this negative slope, right? So let's say there are some exam score associated with my madness, anger. So this one actually makes me so mad when a student gets just 20%. Okay? More mad. Let's say I'm here 9. 10 is too much, huh? So another student gets like 95%. It should start from 0. But let's say 1. I'm still angry. Why? Because he or she should get 100%, right? So if it was 100%, I would be like, okay, let's don't be angry. So what I'm going to explain here is this. Look, above average of one variable tends to accompany what? Below average, right? And then below average of one variable tends to accompany the higher average. So these are opposite. Do you understand this? So that's what it says. Two variables are negatively associated when above average values of one tend to accompany below average value, and then vice versa. So this is the definition that I just explained. above average accompany the below average of other variable. Below average of one variable accompany the higher average of the other variable. Correct? Do you have any question? Yes.
Would it be right to say that the variables, when you're talking about a negative association, are inversely proportional?
Yes, exactly. They are opposites, correct? So inversely proportional. Right. But you know what? Proportional because what is the proportion? We divide the rates, right? And then the meaning is correct, you know. But if it comes to numbers, maybe we cannot match it with numbers. You know, maybe we cannot divide the numbers and say this is inverse. So mathematically, maybe no, we cannot use that, but meaning is correct. Okay, so inversely proportional. Any other question? Yes.
So the x on the x-axis is supposed to be the response or the explanatory, right?
Do you remember I said if you know which variable's response, it goes on y-axis. Which variable is explanatory goes on x-axis. And also you can use a scatter plot for two explanatory variables. Correct? So let's say these are two explanatory variables. It was a really good question. Because why? My madness, my anger doesn't affect your exam.
That's
Your
what I was
exam,
gonna say.
you know, it's like difficult to, you know, kind of find a relation like response and explanatory. So let's leave it like two explanatory variables. So that's why it doesn't matter where we are putting this variable, x-axis or y-axis, right? Did you understand what's going on? So these are, let's say, just two explanatory variables. So now we have this correlation. We want to talk about the measure of relation between two variables. We are going to use this formula. Most of these parts are familiar to you. What is x bar?
Mean.
Correct. What is y bar? Still, it's a mean. X bar means mean of one variable, x. Y bar means mean of another variable, y, right? So what was S? S is a standard deviation, right? So S with index of x means find the standard deviation for x variable. S with index y means find the standard deviation for y variable. For both of them, mean and standard deviation, you have the formula, right? You just need the numbers to just use the formula and find this standard deviation and mean. So the first step to find the correlation is to find the standard deviation of one variable, the standard deviation of another variable, mean of one variable, mean of another variable, right? So let's use example to explain this formula more and see how we can use this formula. So previously, I used to have more, data in your homework assignment to find the correlation, but now I didn't give you that much of, finding correlation because it's time consuming. Okay, so this is just an example. You are not going to calculate correlation that much, especially in exam. You are not going to, but you should understand how to use this formula, okay? So let's say we have two variables. Let's say this is a score, whatever score, like exam score, any score. And then we have and then we have another variable. Let's say this is the time, okay? And then 6, 7, 8, and 10, 9, 8. Okay, so these are numerical, correct? Numerical. And then let's say, do you remember I said each point has x and y coordinate? So imagine this is one point with x and y coordinate, another point with x and y coordinate, another point with x and y coordinate, right? And then how many points we have? 3 points. If we want to draw a scatter plot, how many points we would have? 3 points, right? How many individuals we have in this study? 3. So n is, small n is 3. Just remember, number of individuals. Each individual will have x and y. So let's call one of these x variable, another y variable, because we want to replace this number. Let's say this one is x, this one is y, okay? So according to this formula, I should find x bar, right? Mean of x means add this one to this one to this one, divide by? Right. So let's do this. And then for y bar, we do the same thing. 10 plus 9 plus 8 divided by 3. And then we have to find s of x. Minus 1, s of y. Minus 1. We have 3 parentheses. I even didn't have to write this down because you should already know how to find a standard deviation, how to find mean. Okay? You should already know how to use this. So x bar is 7, y bar is 9. Right? 7 here. And 9. So the first variable of x, 6 minus 7, which is mean, right? Mean of x. Correct? This is a standard deviation formula. Then 7 is the other, and then 8 is the other, and then all of them. Yeah, this is a formula for standard deviation. And then for y, we have 10 minus its mean, 9 minus its mean, 8 minus its mean. Correct? And the mean of y is 9, 9, 9. If you calculate all of these, you will get 1 for both of these standard deviation. Okay?
Where do we subtract the 1 from? Where do we get the 1 from?
This one?
N minus 1.
N minus 1.
Okay.
Yeah, standard deviation has n minus 1 on denominator, on the radical, right? Right?
Yeah.
So it will be 2. Okay, any question about this? No? So now, I'm going to write down the formula for correlation, okay? So it says 1 over n minus 1 multiply a whole fraction, right? So I will just put n minus 1 on denominator. Can I do that? Yes? And then everything else, all this big bracket goes on top of fraction. So it says x1 and x1 minus x bar divided by s of x. x1 is this one, right? Minus x bar divided by s of x multiply to y1 minus y bar s of y plus. The other one says now x2 minus x bar divided by s of x multiplies to y2 minus y bar divided by s of y. And then plus the last one, because we have just 3 variables, right? 3 individuals, right? That's it. You just replace whatever you have. So let me write down here. This is x1, x2, x3, y1, y2, y3. Okay? Am I right? And then let's continue replacing everything. N is 3. We know that. And then instead of x1, I'm going to put 6. 7 is the mean. 1 is the standard deviation. 10 minus 9, standard deviation. And 7 minus 7, 1. 9 minus 9, 1. Check it, okay? Don't copy paste, just pay attention to see everything is correct and then write it down. 8 minus 9, 1. So continue here. We have 2 here. Negative 1 divided by 1. 1 plus 0, 0, 1, negative 1, right? So 0 divided by any number is 0, right? So we have negative 1 plus 0 minus 1 divided by 2, negative 2 divided by 2, negative 1. So we just found a correlation, which is a measure of relation between 2 variables. And then how we can use this correlation. After you write this down, I will write down all the properties of correlation and how we can use the correlation to explain our scatter plot. Do you have questions? So this is correlation. Do you have any questions? Are you done? Okay, so let's talk about correlation. The first thing about correlation. When we are going to talk about correlation, we should pay attention to the form of relation. Form was either linear or curvature, right? If we want to calculate correlation, form must be linear. Must be linear. If the form is non-linear, what we say? Correlation doesn't make sense. We cannot find correlation. Correlation doesn't make sense. So if the form is curvature, correlation doesn't make sense. If we want to find a correlation, form should be linear. So the first thing here, when we talk about correlation, form has to be linear. Then, the second one, correlation is always a number between -1 and 1 means any decimal between these two, or even 0. So here our correlation was -1, and later you will understand what exactly that means. 1, 2, what I said, R is a number between -1 and 1. 3. Do you remember mean, standard deviation? These had unit of measurement. I always told you find the unit of measurement after finding mean. You should write down the unit of measurement for that variable, right? This much is the mean of, for example, exam score. So we should say mean of exam score is 90%, for example, 80%, something like that. Correct? So unit of measurement. Correlation doesn't have unit of measurement. Why? Because we are dealing with two variables, right? One was, for example, exam score, another was a study time. Exam score has a percentage as a unit of measurement, and study time has hours as a unit of measurement. So it doesn't make sense to choose between these two. So correlation cannot favor any of these variables. So done, we don't have any unit of measurement. It doesn't accept any unit of measurement at all. Correct? So changing of a unit of measurement will not have effect on correlation. So these two are exact same thing. Either you can say correlation doesn't have unit of measurement, or you can say changing of unit of measurement will not have effect on correlation. Okay, so these are the same thing. Then number 4. Yeah, of course you have X and Y in here, and you think, okay, probably one of these is explanatory variable and another is response variable, right? But still we can find correlation for two explanatory variable. So it doesn't matter which variable is response, which variable is explanatory. Still you can find the correlation as long as you have two numerical variables. So first of all, both of variables should be numerical. Second, I said doesn't matter which one is X, which one is Y. Choose one of the variable as X, another as Y. Label one of the variable as X, label another variable as Y. Doesn't matter which one. Still the correlation will be the same, exact same. So the next one I said, doesn't matter which variable is X, which is Y, just label one variable as X, another as Y. Okay? And then now this one I said, I don't want to forget. Both variables must be numerical. Do you have any questions so far? So when I say two variables should be numerical, means you cannot find a correlation for example, age and exam score, correct? Because age is a categorical variable, correct? So as soon as you see a categorical variable, you say I cannot find a correlation for that, correct? So what else? So these are almost all the properties before we, start to even interpret the correlation. So So now how to interpret that number we found? 1. If R is correlation, right? If R is a negative number, so the number we saw was negative, right? And I said correlation can be any number between -1 and 1. So when I say all the negative number means all the numbers from -1 to 0, right? These are all the possible negative numbers we can have for correlation. So let me write it down here. From -1 to 0. These are all negative. Okay? So if we have a negative correlation, what we say? It talks about direction. So if the correlation is negative, the direction will be, can you guess? So how many directions we had? What was that? Negative and positive. So when correlation is negative, direction is negative. So what should I write down negatively? Associate. Okay. So the examples, maybe we say, okay. So these are all the examples of negative associate. R is, let's say, -0.2. Correct? This is a number between -1 and 0. R equal negative, you tell me. Correct? R equal negative, let's get closer to -1.95. Correct? These are all the examples of negative association. When R is negative, we interpret our graph in this way, our relation in this way. Question?
Is this supposed to be 1 and -1 and then R is supposed to be less than 0? No, less than 1?
Oh, -1 is less than or equal to.
Yeah.
Is this correct?
She just asked me what she wrote down.
Yeah. Is this correct? It says a boundary. This is a boundary, right? This boundary starts from -1. -1 can be included because I have a equal sign, right? And then it goes up to 0. 0 cannot be included because 0 is not a negative number. But any number on the left side of 0 on the real number line, right? So R can be any number between -1 and 0. Either you can read it in this way, or you can say R is greater than -1, but smaller than 0, right? Is this correct? Okay. Do you have any other question about this? So this is just a mathematical way of writing down the boundary, right? So R can be any number between this. Now, let's say if R is a positive number, and then now I want to give another boundary. Now the boundary starts from 0 to +1, okay? Any number less than +1 but greater than 0. Huh? No, let's don't include 0 because later you will see what happens if we have a 0 correlation. Okay, you will see what happens. So now you tell me, what should I say? The direction is positively associated. And then let's have some example for this. R should be positive. Let's say positive 0.18. R can be positive 0.4. R can be positive 0.8. R can be positive 0.99. Good? Okay. So if you calculate R and then your number is positive, the first thing you will talk about is the direction of relation, and you will say these two variables are positively associated. Means one variable increases, another will increase. Or one variable decreases, another will also decrease. Okay? So, any question about this one? So now we want to talk about the strengths of relation using R. 3. If R is a number close to positive 1 or negative 1, we talk about the strengths. The strengths will be, so how many strengths we could talk about? 2. What is that? One is weak, one is strong, right? So if correlation is a number close to positive 1 or negative 1, we say the relationship is strong. Doesn't matter negative number or positive number. If number is close to negative 1 or positive 1, we talk about the strengths and say this relation is strong. So if the number is negative, you will say the direction is negative and it's strong, right? If the number is positive, close to 1, you will say it is strong and the direction is positive association. So we will see it on the graph too. But let's just, slowly talk about it. What I said? Strong relation. Okay? So give me some example. R is equal to negative 0.8. Correct? Close to negative 1, right? And the relation is strong. What else? Negative 0.95, right? Seven five. So I will talk about exactly. This is something I should talk about. How close to 1 and how close to negative 1, right? Maybe we'll talk about that. So let's write down all of these and the next one, and then we will talk about the boundary. How close to 1 and negative 1, and how close to 0 and 0. So let's give you another positive 8, 9. Oh, good. And then we talk about the exact boundary, how close it is, how far from. 1 and positive, 1 and negative. Okay, so the last one, if R is a number close to what? Close to 0. Again, we can talk about the strength, but now this time the relationship is weak, correct? So strength, we have a weak relation, and then let's give you some example. What is R? R could be negative or positive, but close to 0, right? Negative what? 0.2. R is equal to negative 0.5. 5. And then let's say R equal positive 4 now. Positive 0.4. Okay? And then R equal to positive 0.6. Do you have any questions? So is this all clear so far? Okay. So now we talk about that boundary I wanted to talk about. It said 0.75, right? So let's keep that as a boundary, because mostly from 0.75 to positive 1 is a strong relation. So let me write it down here. For number 3, I'm going to extend it and say, okay, let's say R between negative 1 to 0.75. Am I right? Negative 1 to negative 0.75 to negative 1. These boundaries are all the negative number close to negative 1, correct? And the relation is strong, right? And then the other boundary will start from positive 0.75 to positive 1, right? Okay. So maybe you consider 0.7 also strong, but let's keep it as a boundary for our classes.
What happens to like the middle? Those numbers that you were just saying at the middle, it's like 0.69, 0.7.
This is the last one, right?
So you just everything under point.
So what should we say? 0.75. I'm not including 0.75, right? Here. So 2, this is negative 2, 0.75. Okay? And these are all weak relations. Okay? So now we kept 0.75 as a boundary. If you have 0.75 positive, that number is close to 1, and you say a strong relation, right? If you have negative 0.75, you will say this number is close to negative 1 and a strong relation, right? And then any number between 0.75 to negative 0.75 to 0.75 will be around 0, right? It's boundary around 0. So what happens if correlation is 0?
There's no correlation.
No correlation, right? There is not no correlation. It means there is not any relation. You cannot find any relation. Because the relation is that weak, we cannot even find anything. Like they are unrelated, these two variables. Correct? So this is the way we explain correlation. So now please ask me your question, so maybe we can talk about this more. Anything? Yes.
So you're saying if zero, if it is zero, it's no correlation at all?
Yes.
Okay.
So I'm thinking about, for example, two variables that are numerical and not correlated at all. They are not, they don't have relation at all. Anything in economic that you cannot find a relation between two variables? Oh, do you remember one time we had this example? I don't know if you remember. Oh, actually, we didn't get to that one. Yeah, the shoe size. There's a study. Later, I will show you lurking variable, and they were studying on the effect of children's shoe size to their exam score. So there were students between age 7 to 12, and they were thinking, okay, if their shoe size is bigger, they have a good score on their math exam. And it is totally unrelated. Yeah, of course, shoe size is bigger means they are older, correct? And they do good on their exam, correct? So the exercise was like finding relation between these two, shoe size and exam score, and there was a really huge correlation between these two. And the study was obviously wrong, and later we talk about lurking variable, and you understand, what was the effective and showing that high correlation. Obviously it should not be a high correlation. Obviously shoe size doesn't have any relation with exam score, okay? So later we'll see that. But now, as an example, there is these two variables. Obviously your shoe size is not related to your exam score, okay? So if you want to find a correlation for that, it should be like 0, not correlated at all, okay? So that's a kind of example for 0 correlation. Okay, any question? Nothing? Okay, so let's look at the graph. This page, look at this on PDF. These are all the properties of correlation that I just talked about, okay? And these are important, all of them. Okay, so now let's look at this. So these are some graphs, a scatter plot. And then you will see correlation for each of these scatter plots. So obviously without correlation you can guess. What you can guess, you can say the form of relation is, for example, linear. You can say the direction of relation is either positive or negative, right? You can talk about the strengths, either weak or strong. But the last one is more difficult. For example, this one, you may say, I don't know exactly it's a strong relation or weak relation. Correct? So in that situation, we need a measure like correlation to help us to judge, right? So let's review this first. How we talk about the strengths when all the points are close together on the line, around the line, what we say? Strong, okay? So you remember that. And then weak relation means all the points are far from each other, far from the linear line, right? Okay, so you remember this. So now let's talk about this. Let's start from this one. Okay, without maybe looking at the correlation, the form is obviously linear, correct? Because you can pass a linear straight line through all these points. So the form is linear. So what is the direction of this? Negative or positive?
Positive. Negative. Wait.
This one.
Oh.
I'm covering.
Oh, okay.
I'm covering this line.
Negative.
So what is that?
Negative.
Negative. Correct. Negative. And then strength.
Strong.
Strong. So we said a strong relation. We said positive direction. So let's think about correlation. Positive R means positive direction, correct? So in this case, we should see negative R because the direction is negative, right? We should see a negative R here and then negative R. And it should be strong, means close to -1, right? So look at the correlation. Negative and also close to -1. Okay? So it explains a negative direction and also a strong relation. So now we compare the next one. Obviously it's still linear, correct? So direction this time is positive. Correlation is positive, correct? Almost strong. Actually, you can say a strong relation because these points are all together. The correlation is a positive number and close to +1, but not as strong as that one, right? Because 0.99 is obviously stronger than 0.9. Okay? So, any questions so far? So let's move to this one. So obviously linear and the line is like to this side, means the slope is negative, correlation should be negative, okay? So we know there should be a negative number, but now we want to talk about the strength. Obviously compared to previous, this is not that strong, right? So that's why you will see 0.7 as a correlation, okay? Is that clear? So, this. And then, this one. So, the line is going from this way to that way. So, the direction is obviously positive. Correlation should be a positive number, but not as strong as the previous one. So, the number we see here is 0.5. You consider that as close to 0, right? That's why it's almost a weak relation, okay? The next one, that one. So, yeah, maybe you can see a linear, imagine a linear line passing through all this, and the slope is negative. So let's say negative association, and R is actually approving that negative number, right? And the relation is not that strong, means we have a number close to 0. And then the last one, you don't see any relation at all. Not strong, it's so weak relation, correct? So R is 0. No relation at all. Do you have any question? Yes.
How much does R get affected by outliers?
Next time, chapter 5, we will talk about outlier and how outlier will have effect on correlation. But maybe we can, because we still have time to talk about chapter 4, maybe now I can just give you a kind of clue what happened exactly. So let's say we have a scatter plot like this. And then imaginary line passing through. And then let's say we are talking about the exam score and study time. Actually, exam score and working time. Because that working time and exam score had a negative relation, right? Do you remember?
Yes.
So if you work more, means you don't have time to study and then your exam score is bad, right? So negative relation if you remember. This is negative too. So now let's say there is an outlier here. There is a student, even though worked almost 10 hours that day, but still the exam score was like 95%, 100%. So this considered as outlier, okay? because it's totally different from other, exam scores and other individuals. So now, before this, let's say the relation was so strong, we had like negative 0.85 as a correlation, means correlation is so strong. Yeah, of course, the direction of correlation is, showing a negative association, but a strong relation, right? Is that correct?
Yes.
If this time, let's say we have an outlier here, this outlier will change the correlation. This correlation will not be strong anymore because there is a new data, there is a new X bar we will have for everything, there is a new Y bar we will have for everything, correct? And Y bar, X bar were not resistant to the outlier, they change a lot. And our correlation has Y bar, X bar, S of X, S of Y, and these are not resistant to outlier. So what happens? Correlation is also not resistant to outlier. So correlation easily will change, get affected by outlier. So this outlier will change the correlation, and this new correlation is maybe negative 0.6, something which is not showing a strong relation. Am I right? This is almost close to 0. So this is the change from this one changes to this new correlation. So in another word, correlation is not resistant to outlier. Correct? So let's write this down. Correlation is not resistant to the outlier. In parentheses, because we have X bar, Y bar, S of X, S of Y, which are all not resistant. Okay? So this is the effect of correlation. Actually, maybe that was a good thing we talked about this now. Give you an idea of what exactly correlation can do. Do you have any question? So this is a scatter plot, correct? We said a scatter plot shows the relation between two numerical variables, correct? On x-axis we have numerical variable, on y-axis also we have numerical variable. After we draw a scatter plot using two numerical variables, still we can affect or add a categorical variable to our data set in this way. Still x and y are numerical as you see, but we just kind of categorized our individuals and separated them with different color. So if this data is % of graduate taking the SAT exam, we saw this before, right? And we have a state mean SAT mathematics score. Even though these are numerical, we can separate them using a categorical variable, different state, and showing them with, for example, blue color. And blue color shows us this is Midwest states, these individuals, this data, and then this data with a red plus kind of shows different states, northeast states. So if we want to add a categorical variable to a scatter plot, we can do that. Just we should be careful to separate them using different color, different shades. Okay? So, do you have any question? So let me see what kind of, you also think about, your questions, maybe something comes to your mind, and then I will find some examples. Okay, so we have example here. So we have this scatter plot, okay? Do you see that? Yes. Okay, let me maybe move everything. Okay, here. So there are two questions about this scatter plot. It says, first of all, it says, use the information and a scatter plot to answer questions 11 to 13. Relation between measured weight in kilogram and self-reported weight in kilogram means the real weight and the weight people think about their self, correct? And then it says a scatter plot of this data is given like this. So measure weight on x-axis and then self-reported weight on y-axis. So what kind of form we see here?
Linear.
Form is linear. Okay? When I ask you form, either linear or curved. So linear. So the question here says the form of this relation is linear. This is the correct answer. Correct? And then it says a plausible value for the correlation between, what should I say? Let's say x and y. Okay? Because we already between these two variables. Okay? Okay, what's the answer?
C.
Right? Because we have a positive association first of all, correct? So correlation should be a positive number, right? And then there is almost a strong relationship, so it should be close to +1. So the number we choose is 0.8, correct? So first of all, positive number, so our choice will be either this 0.2 or 0.8. Between 0.2 and 0.8, we choose the one which is closer to +1 because we know we have a strong relation. Do you have any question? Okay. So these are kind of questions you will see on the exam. And then now let's ask you some question about response variable and explanatory variable. This is a good question. It says archaeologists often find only parts of ancient human remains. For example, they may find a small finger bone called the metacarpal bone. Is it possible to predict the height of a human from the length of his or her metacarpal bone. So, first of all, I want you to tell me and find the response variable and explanatory variable. Because we talked about that, okay? We should know how to find the response variable, how to find the explanatory variable if you have two variables, right? So, you should think about one variable has effect on the other variable, correct? Explanatory variable always has effect on response variable, correct? Explanatory variable can change the response variable, correct? Those 4 sentences I gave you. Okay, so read this again. And then you should be able to first find the response variable. So as soon as you find the response variable, obviously, you know which one is explanatory variable. So metacarpal bone. And then another one is height of human, right?
Yes.
What will have effect on which one will have effect on which one? Right? So this one will have effect on this one. So what is the goal of a study, focus of a study then?
See if there's a relationship between.
Okay, good. What is the response variable? This one? So, great. So we call this y, right?
Yes.
And then the other variable is x, correct? Because we know explanatory variable has effect on y. So now, let's continue the question. Because this is the main part. We should know this first to be able to answer the question. It says, to investigate, a researcher measures the height and metacarpal length of 200 adults. In making the scatter plot, the researcher should first determine if the height of human follow a normal distribution. We didn't even talk about normal distribution when we were drawing scatter plot, right? So totally wrong. A. Agree? B. Use a plotting scale that makes the overall trend roughly linear. Can we force a relation to be linear? No. We just look at the scatter plot and say either linear or curvature. We are not going to, manipulate to do anything. Correct? So B is also wrong. Plot the metacarpal length on the horizontal axis. Is that correct?
Yes.
Why? Exactly. This one goes on x-axis. So C is the correct answer, right? Because this one says now plot the y variable on x-axis, which is wrong, right? Oh. Do you have any questions? So these are questions similar to your exam. So if you understand it now, means you will not have any problem for the exam. Then let's see one more question. We have 5 more minutes. Okay, look at this one. Look. It says a researcher states that the vaccination is negatively associated with illness. So how many variables we have here? What are those?
Vaccination and illness.
So how you can explain the negative association between these two? Means if vaccination increases, illness will
Decrease.
Great. Okay? It says choose either of these. I mean, one of these depends on this one. Correct? As people get more vaccination, illness tends to increase. No, correct? So this is wrong. Because we just said, as people get more vaccination, illness should decrease. So B says, as people get more vaccination, illness tends to decrease, which is a correct answer, right? And then we could also talk about this below average. Do you remember? It says below average value of vaccination tend to accompany below average value of illness. It should not accompany together because we talked about that. Just we start this class. We said below average happens with above average if we have a negative association, right? So that's why it's not correct. And then the last one is even talking about something else. Older people. Yeah, older people are like. Okay, do you have any question? So we are done with chapter 4. You are able to start your homework assignment. And then on Wednesday, we are going to start chapter 5, which is connected to this, everything I talked about. If you don't have any idea we talked about, you should review everything and be prepared for chapter 5 because these two are related. Okay? Okay. See you on Wednesday. Take care.
Like if you pay attention to this fucking chronology. Because I have no idea what the fuck we're talking about.
That cannot.